Eric. All right. So I'm Tom Bassett Dilley. I'm an architect and passive house consultant, and I want to thank Michigan for having me from Illinois. And I want to say that my mom grew up in Detroit in the end of the Golden Age, and my dad on a fruit farm just west of South Haven. And every summer as a kid, we would go up to northern Michigan, Charlevoix, and Traverse City, where I have family. Um, leave the sweltering heat of Indiana, where I grew up, and go up there and just connect with nature, connect with family. And um, that really instilled in me a love of nature, and and it put it together with being with family that has really been a big part of why I do what I do in architecture. So I'm going to talk a little bit about the why, not just the how here, but I want to get to the how. So I'll move fast. Is anybody timekeeping? Okay. You, at 5 minutes. Okay. Well, hopefully I don't have like half my slides at that point. So I want to talk about water because water's not abstract. Climate change is abstract. Um, it's getting less and less abstract. But this is a picture of my daughter and my little niece last year up near Empire, Traverse City, Sleeping Bear Dunes area. Um, really, to me, one of the most beautiful places on the planet that I've seen. You know that. Yeah. Oh, jeez. Yeah. See, that's my dream. Um, but but the thing about water is it's our happy place, right? It's where we go for replenishing ourselves. We connect with nature. We connect. We have our beach time with family. All that. Um, and water is life. It's what we come from. But water is also a report card. So all the stuff that we do in the world with emissions winds up in the water. Everything we do with garbage winds up with the water. So if water's a report card and you've got plastic islands the size of Texas in the ocean, you're getting a D minus. And so if you clean it up, you might pass the class, but if you don't, um, you're going to fail. So um, so I kind of look at it as this sort of model of where do our houses fit into this big picture? And this little diagram I sketched up is like a coal power plant, right? So the machine model that we've been running on for the past few centuries has kind of got us to where we are. And so you put whatever you want in there: coal, oil, gas, and however you get it, you frack it, you drill it, whatever. And when you burn it to make a lot of energy, it goes into the air and it goes into the water. Anything that goes into the air winds up in the water, right? So, um, and why are we producing all this energy? Well, it's because you look at that little row of thin little squares down there. Those are our buildings. Those are our homes. And they waste most of the energy that comes to them. Most of the energy, the majority of the energy that you get is wasted. So that waste, goes and we throw a lot of stuff away. And of course, we just figured out where away is. We used to, when there was a million people on the planet, you could throw something away and you'd never see it again, right? But now, away is the water. You see where I'm going with this? Um, so, so who, I ask you, does this really benefit? Does it benefit the people in those thin little boxes? I don't think so. I think it benefits the people who own that big production machine that you have to write a check to every month. Um, and so back to the report card, when Michigan Live says don't touch the water, that is a failing grade. So we got to do better. What can we do? What's the different model, right? So um, you read another page in the infinite book of nature, and there's so much to learn there. And the model that I look at, my dad was a biochemist, and so I'm always looking at like cell diagrams as a kid, plant physiology, photosynthesis, like that's what we're talking about with solar photovoltaic, right? So now I got the little boxes really thick because I'm a passive house guy. I like insulation, I like air tightness, I like keeping the energy in the building. So if you do that, you don't waste most of your energy. You keep most of your energy. You use it. You don't throw it away. And if you put little bits of solar on those things, you're producing. And so if you're not using a lot and your neighbor is, your energy goes back out into the grid and it fills the holes. And so suddenly you take that centralized thing and you decentralize it. And it's a really resilient scenario because you don't need a big plant that if it breaks down, everybody goes into blackout, right? you've got this, and if you've got backup storage, whether at the utility level or at the personal level, man, you can survive. You can survive that. You know that the line the line outage, whatever. So this is a really different model. It goes from that kind of the man down to the people, to put it in that that power to the people. But I ask you, who is this good for? Is it better to live in a leaky, uh, sort of expensive house, or is it better to live in a really well built, comfortable, healthier house? Because if you control the air barrier and you ventilate right, you've got a healthier environment. Um, and who builds those? You know, what's the difference between those thick boxes and the thin boxes? It's the construction quality. It's more labor, it's more work, it's good for the local economy. So, all right, enough of the philosophizing. Um, well, I could do that all day. Um, I just want to tell you a little bit about where I'm coming from here. I've formed the firm in 2006 because I really wanted to go after this idea, which we were at the time calling green, and now we're calling sustainability. But to me, it's the sanctity of life. That this is a beautiful world, and that is the reason to do uh, things right. Really, I mean that's the ultimate goal. So we say our mission is healthy, beautiful, efficient buildings for a clean energy future. Um, Towards that end, I got my passive house training so I could figure out how to design the world's most efficient buildings based on conservation, not just on um, renewables, et cetera. And so we've done a lot of passive house certified buildings. We've done some LEED certified buildings, Green Star for a renovation project, and DOE Zero Energy Ready Homes. We've done them frame, ICF, SIPs, and modular prefab. And every time you do something new, I've learned you're going to take some lumps. So we've taken some lumps, but we think we got it figured out. We're going to keep going. And so I want to tell you a little bit about what we're doing and why we're doing it. Our in the office and in the architecture profession, we're using Architecture 2030 sort of as our measuring stick. Um, the goal is to get the buildings contributing to the solution, not the problem. Though that means that we want to get to carbon neutral in the building sector by 2030. So right now we need to be below 70% savings off of baseline EUI, energy use intensity. So we measure every year and submit our portfolio to Architecture 2030. And last year, our portfolio was 76% below. So we're better than that 70% target. We feel we're on track. We're really happy about that. And but we got a ways to go. So we can take those really efficient buildings that we do and put a little solar on them, because a lot of them are efficient by means of conservation, not simply by means of production. So, and that's really the passive house approach, and we'll talk about that in a sec. So over the past, gosh, um, Molly, what year did you draw the drawings for that blue build, that Lima house? It was 2013, right? 2011? Okay. So over the last 8 years, 9 years, yeah. Molly was working for me then. It was just it was the first certified passive house in Chicago region. So we were really thrilled about that. So we've done a number of these, and these are net zero. A few of them are actually net zero in terms of the solar is on from day one. A lot of them are passive house certified or zero energy ready homes. Um, so this is kind of a lot of residential work, a few park district projects. Um, just quickly, the methodology we use, it starts with, well, it starts with the design, of course, and a conversation with the client and what are your goals. And we got to get aligned and make sure that we're all as a team, builder, architect, owner, after the same thing here. Are we going to go for net zero, net positive, living building, LEED, passive house? What's the motivation, right? So once we identify that, we start the sketches, but we start an energy model right away. And the idea of the energy model is that we're going to optimize the design of the building for the site, for the construction methodology, the mechanical systems, the windows, the geometry of the building, how many windows and where they are. All that stuff feeds in. We use WFI Passive, which is the Passive House Institute US energy model. And so once you have that model, it says, okay, here's how much energy you're going to have to put into this building every year to run it. Then you know how much solar you're going to put on to offset it. You can't do it without an energy model. I mean, you're just guessing. And so, um, and I'm not saying that that's not a valiant thing to do. If you do a really well insulated building that's ventilated and good building science and all that stuff, you're still doing a great thing. I'm not saying it's foul if you don't energy model, but if you want to get to net zero, you really want to know what the dials are and just really optimize it. That's the thing. So that energy model really makes us know how we can conserve, how we can optimize the envelope, um, and then from there we go to production. We go to solar, typically not wind. And this is an output page from Woofy Passive. And this is interesting. The red X's are showing that we're not making the passive house certification targets, but we did make net zero. It's hard to read here. The bottom, the next to the bottom tab is site energy, and you can see that we're producing about 5,000. Well, this is in kilo BTUs. Sorry, about 1,800 kilowatt hours a year more than we're using, and this is a house in Springfield, which I'll show you a picture of in a sec. So how we design it, whether we're doing a certified passive house or not, we use the methodology and the thinking of passive house to optimize the envelope. And so the key things that we've come to are ideally you want a compact form. You don't want a really sprawled out form because that has a lot of surface area and you're going to be losing a lot of heat. The analogy I like to use is my cats. In the summertime, they're sleeping on the bed. They're like this, you know. In the wintertime, they're just curled up in these little balls. So we're designing for the winter loads typically, uh, and, and even in the summer, compactness is going to make it easier to control your energy. So good orientation goes with that. You know, you're going to make sure the windows are in the right place. From a solar standpoint, you don't want to overheat from a big blast of western sun. Um, you know, this is a thing about lake homes. You got to be careful with shading or really low solar heat gain coefficient glass. So that all goes into this energy model and lets you see how you're doing. It's really fun to tweak those things and just watch the numbers pop up and down once you get that model populated. Um, so that's kind of the really big picture stuff. But then next thing is airtightness. Tim, you're right, absolutely right on. Airtightness is key, not only from an energy standpoint, but from a durability standpoint. Because if you have your bulk air leaking through your envelope, you're going to get condensation issues. You know, there's a lot of things about airtightness that is absolutely rock solid important. So the airtightness strategy we diagram with this little red line that kind of goes all the way around the envelope. And so here we got a slab on grade house. The foam is going underneath the foundation. They make these little J forms that you can do that with, so you don't have to try to do what we did here, which is form it on site. The foam keeps falling away because it's a bond break. That was frustrating. But then we've got stud walls with cellulose. We have continuous foam on the outside of that. And so the sheathing is the air barrier typically for us. Now, these days we're using zip sheathing a lot of times. You just tape the seams and you make sure that all your penetrations are taped off to that, all the windows, the electric service, the plumbing service, whatever is penetrating is really well sealed. And you test it with a blower door and make sure that you're good. And then you wrap it with the insulation and the siding. So the thing is that this airtightness strategy has got to be really well thought out where wall goes to roof and where wall goes to foundation. These are the critical junctures, and there are some pretty straightforward techniques, but they take a team approach, you know. So yeah, study those things, get them nailed. And then, of course, part and parcel with that is looking out for thermal bridges. So this is one of the things that as an architect, especially one growing up on Frank Lloyd Wright, just seeing all these fabulous cantilevers, you know. A lot of those cantilevers like piece of steel from the inside, piece of steel to the outside. And what's that steel doing? It's not just sucking energy out, but it's also hitting a dew point temperature in there somewhere. And of course, it didn't matter in his day because there was no insulation. You were just pouring heat through the assembly and you were drying that assembly out. It's great. But when you start putting insulation in and you start making it cold and you start stopping the air a little bit, then you get into real problems. This is one of the things they drilled into us in passive house training is you have to think really carefully about where the condensation is and how you're controlling the air. Um, in construction, well, building science is something that, like I was saying, we always get really kind of drilled in. And I just would encourage everybody, if you haven't been there, to go to buildingscience.com or get Joe Stebrick's Builder's Guide to Cold Climates. There's so many good principles in there, and there's so many good examples. And it's funded by the DOE Build America program, so it's all free online. It's a fabulous resource. That is in construction or in design, thinking about where condensation planes are and how you're managing bulk water, et cetera. But in construction, it's key, making sure that it gets implemented like that. You don't have your voids and gaps in the insulation, et cetera. The construction thing that we've really seen is how important quality control is. The crew, it's not just the GC getting it, it's all the way down to the crew, particularly the framers, the electricians and mechanical, anybody who's penetrating the air barrier or wants to penetrate the air barrier, really needs to be on board with how things go together and what's important in, what are the goals for this project. The diagnostic stuff in construction is really great. We really encourage all our clients to get all of their buildings third-party verified, so we can have a blower door test, a couple times. Even if it's not getting verified, we want the blower door test there early before drywall's up. When the air barrier is open and we can deal with it, we can fix holes, etc. So quality control. All right, case study. This is the third or fourth passive house we did. It's in Hinsdale. It's right on the train at Bowdoin and Hinsdale Avenue. And these assemblies are kind of over the top. What's interesting about the passive house standard is it's sort of changing on a code cycle like every 3 years. And they've reduced the demand on the envelope requirements, increased the demand on I should say, made it more stringent on the overall energy standard. So the standard has like 3 different main targets. Your mechanical system demands 5 minutes. Okay, all that time I lost here? Okay, then you gave me credit. Okay, good. And then so anyway, this is 2015, and we had an open roof, so we poured in cellulose to R95. We kind of overkilled it. The walls are 2x6. It's kind of hard to see there. 2x6 with cellulose is really conventional in terms of the framers. What's odd is what's outside of that, which is 5¼ inches of EPS. And it's 5¼ because we did 2x12 bucks, so we could frame the walls with the window bucks in place with 2x12s, tilt them up. So once you have the 5½ and the ½ inch sheathing, and then you've got your buck on there, you fill that out with foam. It's just a solid lumber framed roof. So we have our air barrier transition basically at the top plate. We do a 5/8 inch little piece of zip in there, actually a ½ inch, because that's what we use for the air barrier. ½ inch piece of zip before the framing sits on there. So that makes a really clean joint. We don't have to like try to lay a membrane in there. It's just a way to transition from our sheathing air tightness to our underside of roof framing air tightness. We do the same thing with a truss roof. This is pre-wired for solar, so we hit an EUI energy use intensity of 11. That number means 11 BTUs per square foot annual. I think baseline is 44, so that's how much you can save just of overall energy use by going passive house. So we can get to net zero with the 7.5 kilowatt PV array, 25 panels facing south. This little house in near Springfield, Illinois, is net zero. It's a LEED H Gold certified by Brett. 2,000 square foot house. Well, I should say it's designed to be net zero. We don't know until it's done. There are no net zero buildings, just net zero users. The thing is, we want to be able to use our buildings and be comfortable and have the lights on at night and stuff like that, and still get to net zero. So this has a little guest house that's detached, so you can kind of be low power mode. She's living there mostly by herself with her dogs. But the low power mode guest house, you can basically ramp it up when she has her kids stay or when her architect comes to visit because he loves the house. And so we've got foam under the slab, foam on the outside of the concrete, and then we're using 2.5 inch InsoFast, which is an EPS product with integral ribs. So the siding just goes on really easily. We keep evolving away from having to make the GC do multiple passes around the exterior for the wall insulation, which I'll get to in the next slide, which is the simplest one that we've come up with, and we're building it this summer. But basically, it's 2x6 wall with 2.5-inch zip R. So what we've done in the past is like you frame up the wall, you put on the zip, you air tighten it, and then you make your first pass with the foam, and then a second pass with your foam because you have to stagger the seams, and then you put on your WRB, and then you have to figure out how to tape that WRB back to all your penetrations for water tightness and air tightness, and and then you have to, weather resistive barrier, yeah, yeah, I'm moving too fast here. Your Tyvek, and so and then put furring strips on, and then your siding. It's like it's 4 passes around the exterior, and it's nuts. So with the 2.5-inch zip bar, which is a basically structural sheathing with polyiso insulation, really efficient foam insulation board. That's just one pass on the outside. You can do it before you even tilt up the wall. And then you just put your furring strips on your siding. We always put furring strips and back vent our siding because it makes it last longer. It's a good pressure equalization strategy too. So so that's really easy way to get to a passive level wall. And then we got really sick and tired of trying to put something on the outside of the foam and the outside of the foundation because it's right down there at the ground. It's either going to rot or rust or get kicked. So we put it on the inside and just do a bunch of foam kind of in that that zone where the where the rim joist is to mitigate the thermal bridge. So mechanically, we're always, all of these houses that I showed you, everything is all electric. Okay, so we're not using any gas in any of these buildings, so we can truly get to net zero because you can't just undo the gas that you burn. So the mechanicals, we've learned a lot working with Mike and Mitsubishi team and our mechanical consultants, but we're doing our own manual J and manual D for duct sizing, equipment sizing. We always have energy recovery ventilators in these buildings to ensure good air quality. And so it's exhausting, that's the blue lines here, it's exhausting out of bathrooms, laundry, kitchen, any place where humidity or smells are made, indoor pollutants, and it's bringing fresh air into the bedrooms and into living spaces. Now, we did some early passive houses with just one, sometimes 2 ductless mini splits, and we just found that you close a bedroom door and the temperatures vary too much. So especially with the ERV pumping in there, because the ERV, if it's not a conditioning ERV, it's going to be making the air a little more humid, a little warmer in the summer, and then the opposite in the winter. So we just said, you know what, we're going to duct to the bedrooms, period. So what's nice with the Mitsubishi suite of indoor products, and I'm not getting paid by them, it's my experience, all right, is that they have low static units and medium static units so that you can blow different distances for ducting. So this diagram here, we just got a little soffit in the upper hall above that where you can see it says flex. And that just ducts to the bedrooms for conditioning only on a separate outdoor unit. So you can set your set point independently of the downstairs unit. And because we have this open plan on the first floor, we can just do one little ductless mini split and we're done for, pretty simple, really energy efficient and controllable floor to floor. So we're doing heat pump water heaters. We prefer a unit like Sandon because it's got an outdoor unit instead of this indoor unit. If you do an indoor heat pump water heater, it's working as an air conditioner and dehumidifier, which is great in the summer, but not so great in the winter. If it's in a separate closet, it's not a big deal, but we had one where it was the closet right next to where the owner sat and did her sewing. She's like, God, the floor is cold. And we're like, oh man. So there's some issues to know about with the heat pump water heaters inside. Oh, I could talk about mechanicals. I just want to say this, what we did was really early adopter stuff, and we were experimenting. We've got, there's so many answers now. So many people have done it. And if you're not familiar with Rocky Mountain Institute, check them out. Check out this paper, The Economics of Zero Energy Homes. It is so attainable now. They're showing here in this slide, if you can read Chicago Climate, they're saying incremental cost to go from code level to zero energy ready is about 1.5%. So to go to full zero energy, putting the solar on, more like 6.5%. It's true, Illinois, the incentives are crazy good. So anyway, check that out. That's good. That's good backup and data. So I am so thrilled to be with my people, um, and to say, this is attainable. We can do it. We can clean up our water. We can enjoy this world. We can build um, a, a really a beautiful future for ourselves. So thank you very much.